Thanks everybody for coming. I'm really glad to see so many people here. My name is Carrie Bobier-Tiu, and I'm the manager of our control team, which is part of our autonomous driving team, and I'll talk a little bit more about what that means in a minute. But first, I'm also going to tell you kind of how I got to TRI. So the first kind of engineering project, hands-on project that I worked on was I was a member of the solar car team at Stanford University when I was an undergrad. So it's the picture upper left for you guys. But I worked, as you can see, on a team of me and a bunch of guys, pretty much. And we built this solar car and raced it from Texas to Canada, cutting out over a week one summer. And that was kind of my entry into cars and my love for cars. A lot of hands-on experience there in engineering, and also met who would become my advisor for my PhD and kind of build the next many years of my life at Stanford. So Chris Gerdes is a professor at Stanford in vehicle dynamics and control, and I started talking to him about suspension design for the solar car, really got along with him and his students in the lab, and ended up staying in the lab for the next 8 years to do my master's and PhD there. The two cars that you see that kind of look like black dune buggies are the vehicles that I worked on there. The top one I used for my research, which was based around safety systems and advanced stability control, and how we can kind of take the stability control that we have in vehicles on the road to the next level by having advanced sensing capabilities. And I also worked on building a new platform, which is the car on the bottom. Two students and many after us, we worked on this car together, and I worked on designing a suspension system that can enhance friction estimation capabilities. So I really got deep into vehicle dynamics and engineering here. I was really hands-on with it. I liked building cars and our test beds and working with all the sensors and computers. But when I graduated, not that long ago even, there weren't really any autonomous driving or vehicle control jobs in the Bay Area. So I went to work at HCST, which is a hard drive company. It's now part of Western Digital. But I'm really glad that I went and worked there, because I got the experience of designing a control system for a product that you had to have this controller that worked on millions and millions of devices that were going out to customers. So I think having that product experience early in my career was really helpful to me in seeing how to design a robust product and a robust controller. I also got into CrossFit there and got to work with my husband, who's the second from the left in that picture with all of the red shirts. They had a CrossFit company, a CrossFit gym at the company, which is really cool and kind of has spurred my interest in health since then, which I'm really appreciative. But I really missed working on cars. So after a couple of years, the autonomous driving business was kind of starting to pop up, and I went to work with a few of my old lab mates at Renault, which is the sister company of Nissan, for those of us in the United States who aren't familiar with Renault. But they have a small outlet here in Sunnyvale, so we built this test vehicle, Cali, the white car with the stripes. And it was just a team of 3 of us. We were working on controls research. It was basically an extension of my PhD. We were all kind of coming from that same background. So I had kind of the research experience there that I was really enjoying, but it wasn't going anywhere, like into a product or out into the company, and we didn't have a lot of support from the Renault or Nissan itself to do that. So I was starting to look for something different. And what drew me to TRI was a couple of things. One was that continued ability to do the research that I was really engaged with, and continuing on for my PhD and bringing that experience with me. And the other piece of it was the ability to work on a safety system that would go into real vehicles. So around the time that I was at Renault, I had a son, so it became very important to me to kind of like figure out how to make cars safer for my family and for everyone that I know. And since I have that background and expertise, I was really excited to come here and work on the Guardian system that we have, which I'll get into in a minute. The other thing that's really great about TRI is our ability to do research with universities. That's been mentioned a few times before, but this is the bottom last picture is me with some of the students at Stanford. We went out and got to drive around with one of Toyota's drift drivers. So, TRI, we have kind of two approaches to automated driving. So we think of it as one system, but two modes that are built on the same technologies. The first one is Guardian, which is a parallel autonomy system where the driver is still in control of the car. So we try to follow the driver's intended commands, but with minimal and intuitive interventions to maintain safety. And then the second half of our automated driving stack is the one that more people are familiar with in general in the industry, which is the fully autonomous system, where the autonomy system is determining some kind of policy for the vehicle to drive, and we calculate commands that can maintain the safety of the vehicle, like for steering, acceleration, and braking. So how does my team's work fit into this? In the autonomous driving stack, as we call it, which is kind of the full set of software that runs the autonomous vehicle, we have some large groups of kind of algorithmic expertise or design. So there's a perception system, which is taking in all the information from the sensors of the vehicle and figuring out, like, what does the road look like? Who's on the road around us? And then on top of that comes the prediction system, which is, we know what's happening now, but what's going to happen in the future. And finally, planning. So what should the car do given what the environment looks like? Or in the Guardian case, what do we think the driver is going to do in the near future? And control is a part of this planning problem. So what my team does is something that we call envelope control. It's something that I started developing, as I mentioned, when I was doing my PhD. But envelope control is a holistic control scheme that keeps a given system inside a safe operating regime or envelope. So we have a few things that we have to do. One is stay on the road and don't hit anything. Two is to maintain stability of the car. So, for example, if you're driving on an icy road, you can lose control of the car and spin out, so we're trying to prevent situations like that, or situations where, like, a kid runs out in front of the car and you might not have time to stop, so you have to swerve around them. We also don't want to ask the car to do something it can't. So if it can't swerve around for some reason, there's something in the way, like, don't ask it to do that. If we don't have enough steering capability or enough or the ability to brake fast enough, we can't ask the car to do that, so we need to know what the limits are. And finally, for the Guardian system, we want to give the driver as much control of the car as possible, but help them maintain the safety of that vehicle. So the technology that we build kind of incorporates all of these things together, and that's how we, here at TRI on the control team, are trying to create an uncrashable car. Thanks. Woo!